take the volume off. Huh? All right, there's the formula for arc length Stacy just gave us right on top. But again, I can't stress this enough. That formula can only be used if your arc measure is in what? Degrees, degrees, degrees. What if it's in radians? I have a new formula for you today. If that arc measure is in radians, and here is the formula. And I'll tell you what each piece means in a second. Theta equals S over R. And I show this to you because it's a little bit easier to use than the top one. Okay, here you go, theta. That's your central angle that's in radians. Central angle in radians. Anybody want to take a wild guess what R is? We're dealing with circles. Radius length. And finally, the S value. That is your arc length. That is your arc length. Yep. Yeah, that's fine. Yeah, I don't know, that's how I write my lowercase s's. I just happen to do it in cursive. Yeah, any lowercase s. All right, some people don't like to use this because most of the time I'm going to ask you guys to solve for the arc length. All right, so instead they like a formula that's already solved for S. Can I get any help right here solving this formula I just gave you for S? What do I have to do on both sides? If I want that formula solved for S. Here you go, 9. If I want that formula solved for S, what do I have to do on both sides? Yeah, you're right. So S is going to be the same as saying theta times the radius, or SOR, as some people like to call it. Okay, so either version works. Again, when do I want to use this formula? If I'm asking for arc length, but the angle is in now radians and not degrees. I'd use that one in degrees, this one in radians. All right, let's try it out. Okay, so for both of these circles, find the arc length. But, all right, everyone stop here. Identify. What's my angle that I'm given? What type of units is it given? Radians. All right, so I probably don't want to use the top formula unless you want to convert it. Does everyone see? You got options here. You can use the formula I just given you guys, or if you prefer to remember just one formula, convert this to degrees and use it over 360 times the circumference. It's up to you. Okay, it is up to you. All right, we're solving for S. I'm going to keep with S equals theta R. All right, S is the arc length, which is what we're trying to find. Theta, central angle in radians. Central angle that's given in radians, 10. Thanks. 6. It's pi over 3 radians. Yep, pi over 3 radians times the radius length. I'm not going to ask anybody about that. 5. What are our directions? Is this a terms of pi? Is this nearest integer, nearest tenth? What do we got? Neither. Nearest hundredth, so I can plug the pi button into my calculator and round. And nearest hundredth, what are we looking at here? 2. Nice, and even added the units. Good man, been paying attention. 5.24 centimeters. Next up, again, finding the arc length, but again, identify what are you given? What is it? What type of units am I in? I see the pi, got to be in radians. All right, got to be in radians on this one. So I'm going to use theta equals, S equals theta R. What is my central angle that's already in radians for me? 19, what is it? 10 pi over 9 times that radius of 27. What do you got? Nearest 10th. 1. See ya. 19. Again. Yep. Hey, do you guys all realize you don't need to use this formula if you don't want to? If you rather use the formula we've been using all unit, you have to convert the radians to degrees first then. Okay, but I'm showing you if it's already in radians, there is a formula out there to find the arc without converting it. Questions from you guys? All right, let's go. Other than finding arc length, can I find something else? You're darn right. Find the measure of the central angle now, theta. Find the measure of theta now. What is the central angle? And express your, radians and degrees. I love it. So S is equal to, I should ask you guys what formula you wanted to start with, right? We could have went radians or degrees. I guess I just decided for you. Okay, S is arc length. Arc length on this one. Here you go, 5. What's my arc length now? 8 pi equals the central angle, which I'm trying to find, times 16. Next step. 17, what do you got? I'm trying to solve for theta. Oh, I'm not, what are we doing here? Okay, but I'm not looking for, my answer shouldn't have any centimeters on it, because what am I solving for? The angle, right? So I shouldn't have anything on here. Now, here's my question. This is pi over 2. Stay with me here. This is pi over 2. If I use this formula, what units am I in right now? Radians. So this angle right now is pi over 2 radians. But it also said, okay, I need it in degrees. So this is a review from Friday. Convert it. Pi over 2. Convert it into degrees now. What's the question, guys? You could. Yeah, go ahead. You could. That's another way. Yep, you can use the other formula. I already know this is pi over 2 radians, and I chose to convert it. So what's the conversion from radians to degrees now? Radians to degrees. What do I have to multiply that by? 15. What do I have to multiply it by? $12. 180 over pi. Pi's cancel out. And theta is what in degrees now? $16, what do you got? Oh, perfect. 1. Oh, 19? 90 degrees. Nice job, Maya. 90 degrees. If you wanted to go back and use measure over 360 times pi d, that's fine. You should still get 90 as well. Yep, go ahead.
So why can't you just use the formula, the theta equals S over R?
You could have, yeah. This is just the same version.
I used that.
Yeah. Why? So you should have got theta equals 8 pi S over R 16. That's where we got to. Yeah, but this is in radians, though, so we keep the pi in our answer. That's where you reduce it to pi over 2. This reduces down. This is in radians because you've used this formula. So I know my answer is in radians, which means from Friday, if I'm going to have any measure of an angle in radians, I should probably have a pi with it. So that's where that pi over 2 came from. That's because it says express your answer in both radians, pi over 2, and degrees. So Friday, we had a conversion that went from radians to degrees. That was on the formula sheet, and that conversion was 180 over pi. We okay now? Okay. Anybody else? All right, let's go to 4. And again, hey, you guys want to start out with the other formula instead and solve for degrees first? Does anybody want to do that instead? We want to practice that? Yes, no, maybe? Okay, let's do it then. Here we go, arc length. Let's start with arc length. Here you go, 22. Okay, 15 pi over 7 equals measure of the arc. What am I going to put there? Measure of the arc. X, I don't know. That's what I'm solving for, right? In degrees, over 360 times its circumference, which would be not 5 pi, but 10 pi. All right, I'm following you guys here. Remember, this answer should be in degrees. What are you guys doing now on both sides? If you wanted to do it this way. If you wanted to solve for the degrees first. What do I have to do on both sides here? 28, what do we have to do on both sides? Okay, multiply it by 360. So I get 10 pi times x equals, oh boy, huh? Good thing we got fraction templates, which of course this one doesn't have. Is that a decimal we should be rounding right now? Probably shouldn't be a decimal, we're rounding. So let's see, I gotta do that here. 15 pi over 7 times 360. Wow. Get rid of this. And then dividing both sides by 10 pi. And remember, don't divide by 10 pi. Either put it in a fraction template or divide by parentheses with 10 pi in it. And I'll let you guys, there is rounding here. Let's go nearest 10th, please. Nearest 10th. That angle's what, about 77.1 degrees? Yep. And okay, how do you want to turn in the radians? Hey, okay, let me do it this way. What are my two options now to find the radian measure of this angle? What are my two options right now? I found it in degrees. Great. That's half the problem. What are my two options to find how many radians are in that angle? I could do what to 77.142, whatever decimals on my calculator. I could convert that to radians. Or I could use what formula? If I wanted to get the radians, what formula could I use? I could convert this, what's on my calculator right now, to radians, or use what formula? 14? Which is what? Okay, or S equals theta R. Either one because they're the same, right? Okay, you guys go ahead. You decide. I'm not going to do it here for you. You decide which one you want to do here to get the radians. Convert 77.142857 into radians or use the formula. And since you are going to radians, keep the pi in your answer, please. Keep the pi in your answer. Bless you. Okay. As you're converting, leave pi in your answer. 4, what do we end up getting here? Convert it to a fraction. Convert it to a fraction. I don't want that decimal with a pi with it. Convert it to a fraction, which you should be able to. Really? We got the same calculators, and anybody's converted to a fraction? Or just mine? Yep.
What are the tests are we going to need to calculate
You shouldn't, because here's the other way too. Let's say, okay, maybe you converted this into radians, but you don't have to. You could also use S equals theta r, and that's already in pi. So you're going to have options. Okay, so the answer to that is no. It's not going to be required. No. Because here, okay, say it doesn't turn it into a fraction. Okay, fine. I could still use, okay, my calculator doesn't do that, so I have S equals theta r, arc length 15 pi over 7 equals theta times radius of 5. Divide both sides by 5. Keep your pi in your answer. Okay? There are other ways around it here. It didn't still turn it in there? Okay, that's fine.
No, I didn't do it yet.
No, I was talking to Skylar.
Oh,
Yeah,
okay.
it's all right. No.
I didn't hear.
3 pi over 7? So again, when you do 15 over 7 divided by 5, just do that, no pi in it. And you should get 3/7. Okay, any other questions or comments? 3 pi over 7. You should get 3/7 when you divide 15 sevenths divided by 5. Okay, so applying angle, radius, and arc length to a problem. I should have been more prepared here. The pendulum, usually I need to, anybody know what I'm talking about? Pendulum of a clock? Some people don't, that's fine. It's a little old school. I don't even think some people probably do have them in their houses, but some people do not, including myself. Whoop. There you go. Pendulum right here. There's your pendulum. All right, big grandfather clocks probably have them. All right, everybody good? Pendulum? All right, great. Little outside info for you. We're getting a good one. The inside workings here. Oh, that's cute. Little owl tail. Oh, little Beauty and the Beast, huh? Nice. Little crab as the pendulum. That's cute. The whale. Oh, a little shark. There's no pendulum there. Oh, that is. Oh, look at that. The flamingo here. That's creative. Octopus with a little submarine. The submarine and the octopus. Nice. Actually, I don't even know I don't even think that's an octopus. There's only 4 tentacles there, huh? Squid, maybe? Yep, I'm just making this as painful as possible for you, looking through all the different images of pendulum. Oh, the sheep with the little sheep hanging. That's kind of creepy, but okay. True. Yeah, that's just looking like giving birth there. It's a little creepy. What's anything else? Got the whale again. Nice. All right, there you go. Pendulum, everybody. Let's see, can you purchase that whale? That would look great in my daughter's room, huh? $49. All right. Made in the USA from birch plywood. All right. Ooh, battery's not included. That's a deal breaker. Oh, and even a little spout on top. That's cute, right there. Little pendulum crab. All right, you ready to go? I'm good. All right, so yes, Skylar. Why? I didn't. I don't think I. What do you mean? I used 10 pi as the radius. No, I know that because the 10 represents the diameter. Pi d. I use the arc length if I was given degrees. Degrees over 360 times circumference. This top one right here. Ready? Arc length equals degree measure of the angle in degrees over 360 times circumference. No, you're thinking about the rate. I didn't use this formula here. You tell me. I used the one in degrees because everyone was like, use the one in degrees, use it. So I used it. There's two formulas, Skylar. There's one when the arc measures in degrees, and there's one when the measures in radians. Correct. That's the one I used because everyone was like, use it. So I was like, fine. Okay. And as I'm just figuring out, I just recorded all that. So if anybody's ever, let's see, who's good. I hope these guys listen to the whole thing. Okay. And what are you thinking while you're watching this right now? I'd like to know. So you guys that are out right now, whenever you come back in and you've watched this, let me, or listen to it, let me know what you guys are thinking. All right. And did you watch the whole thing or are you just fast forwarding? All right, ready? Pendulum the clock swings through an arc of 2.5 radians. So I know I'm dealing with radians. If you want to convert to degrees, you can, or we can use theta or S equals theta R. And it travels through an arc of 50 centimeters. Find the length of the pendulum. All right, well, let's just get an idea here. Here's my clock. All right, I got the pendulum swinging through. I'm not going to do anything great like on the images, but it's swinging through an angle of 2.5 radians. So again, pendulum swinging. What's the arc length that it makes? 50 centimeters. What am I really asking for when I look for the length of the pendulum? I'm looking for the radius, yeah. Because here's the pendulum swinging through 2.5 radians. That's what I'm looking for. And again, the angle is in radians. So I probably want to use the arc length formula associated with radians. And again, unless you want to convert it to degrees and use the first formula. That's fine. It's up to you. I just think this one's a little quicker because I'm given all the information. What's my arc length? 50 equals, what's my theta now, my angle measure? 2.5 in radians, and I'm looking for the radius. Divide by 2.5, divide by 2.5. What is the length of this pendulum? Seven?
27
Everyone all right on that one? All right, just one more then. Okay, in a circle. Let's see what I'm working with here. Oh, review, little vocab. Central angle. Describe to me what makes an angle central in a circle. Because I could make a rando angle in that circle right now. What makes it a central angle? I got to put the vertex where? At the center. Yep, put the vertex at the center of the circle. And the measure of that angle is 3.5 radians. Intercepts an arc. The arc length is 24.5. Find the diameter. Now, hopefully that doesn't get head spinning. Diameter? What do you have enough information to find right now? Not the diameter, but you could find radius. Absolutely. This is in radians. So a 1, convert it if you want, or use S equals theta R. Arc length, 24.5. Theta, 3.5 times the radius. And you end up with r equal to 14, nope, sorry, that's the final one, 7 centimeters. So what's your diameter then? Oh, you guys are good. Multiplying by 2. 14 centimeters. All right. Okay, so tonight's homework doesn't look long. It's only 3 problems. But it's a combination of today and the conversions we did on Friday. So I would highly recommend right now in the next, you guys have 6 minutes here, maybe talking with some people, moving your desks around. You could sit with other people if you want and start talking through these here. All right, because I'm going to try to give you as little help as possible here. All right, again, this is a combination of converting degrees to radians, radians to degrees, and arc length, which is what we did today. All right, so move around if you need to. I know you don't like this whole conversing thing.